Okay, hello everyone. Today we're looking at properties of exponents. And it's basically these three properties right here. Okay, and we'll go into them a little more detail. Guys, just looking ahead, this is a slide I don't normally show, a little extra. But guys, this is basically what we're going to cover here leading up to the last final test. Okay, end of last week we covered nth roots and negative and fractional exponents. And today we're going to do properties of exponents and radicals. And then later this week, we're going to graph radical functions. And then a week from now, we're going to solve radical functions. And then we'll have the final test, which just will cover these four things right here. And then the last week will be a catch-up week. All right? So students can do some work and help improve their grade. That's what I'm hoping for the last week. All right, now today's objective is to use the properties of exponents to simplify expressions. Again, these are the three properties we're going to use right here. When you multiply two powers, raise a power to another power, or divide two powers. All right, today's essential question: how can you use properties of exponents? Or how can properties of exponents be used to rewrite expressions? Guys, there's lots of properties of exponents. We've covered a bunch of them already. All right. Basically, these are the six that we're looking at. These top three we already did. The bottom three are the ones we're going to be looking at here today. Okay. Again, these top three, if you remember, raising something to the power of 1 is just the same number. Okay. Negative 1 means 1 over that number. And anything raised to the 0 power is 1. Okay, just a review. That's the top three. The bottom three we're looking at today. Now here's the first one. It's the product of powers. Two numbers multiplied together. They have the same base. Like look at this one, the base of A. This one has a base of 3. This one has a base of X. All right, when you're multiplying powers with the same base, you just add up the exponents. When you take the two exponents, you just add them together. All right, you can kind of see why that works right here with those sevens. And this is a little more difficult example here. Again, this is x raised to the 2/9 power. And this is x raised to the 5/9 power. When you add those up, of course, you get 7/9. That's the answer. And 2 times 3, remember, we're multiplying. 2 times 3 is 6, okay? The rule is down here. When multiplying powers of the same base, you keep the base and add the exponents. And the second rule is a power of a power. Again, of course, you'll have the same base. It is the base. It's just one base. You're taking a power and raising it all to another power. When you do that, you multiply the exponents together. Again, you keep the base, whatever it is, and multiply the two exponents together. Okay, each of these examples does that. This shows you down here why it works. Why when you raise a power to a power, you multiply the exponents. An example up here, remember when you multiply two fractions together, you multiply the numerators together. 2 times 3 is 6. You multiply the denominators together. 5 times 7 is 35, okay, and keep the x. When raising a power to a power, multiply the exponents. All right. Now you have the quotient of powers, or we're dividing a power by another power that has the same base. Now be careful, make sure the denominator is not 0. Okay? Guys, in this case over here, look at this example. 6 divided by 3 is 2. All right, but 5/7, I'm subtracting now 2/7, so I get 3/7. And guys, this is why it works, just because they cancel out. In this case, there's 7 x's on top and 4 x's on the bottom. Well, 4 of them cancel out, so that just leaves 3 on top, okay? Then the rule is, when dividing powers of the same base, keep the base and subtract the exponents. Take the exponent of the numerator and subtract the exponent of the denominator. As this last part, and this is probably the hardest, kind of strangest part, y'all, it is not proper to leave a radical in the denominator of your final answer. And so if you do that like a computer sometimes, it kind of freaks out. You want to make sure that you don't have that. If it happens, y'all multiply both the numerator and the denominator by some number that converts the denominator to a whole number. All right, and moves the radical up to the numerator. Let me show you what I mean by that. Again, we have 1 over the square root of 3. All right, here it is. That's not proper. So how do we fix it? As we multiply it times 1. This is 1 right here. Square root of 3 over square root of 3, that's 1. When you multiply a number times 1, you're not changing the numeric value of the number. We're just expressing it in a different form. Okay, 1 times the square root of 3 is the square root of 3. But the square root of 3 times the square root of 3 is just 3, and this is proper. Now you have a 3 in the denominator. This final answer right here, the square root of 3 over 3, is exactly the same as 1 over the square root of 3. But you want to write your answers like this. All right? No fractional or radical exponents in the denominator. All right, this is a little more difficult example. Guys, it is not proper to have 7 to the 5/3 in your denominator. How do we fix that? We want to get 7 in our denominator, just the number 7. So again, we multiply times 1. But it's a clever use of the number 1. If I multiply this times 2/5, I'm going to add these exponents up. 3/5 plus 2/5, I'm going to get 5/5. And that's what I want. That's 7 raised to the power of 1. That's what I want in the denominator. And the top then just becomes 7 to the 2/5. Okay, this is a proper answer. And this is the exact same numeric value as what we originally started with. It's just written in proper form. All right, guys, this is a summary basically of the 3 properties you're going to focus on. Okay, if you get these 3 down here, you'll be just fine. Guys, so please go ahead, fill out today's notes assignment. It should be relatively easy for you. And complete the vocabulary assessment. And again, participate in the discussion question, which has to do with properly writing the form of your final answer. That's all in the green folder. Please complete the green folder before the next Zoom meeting. Guys, and then prepare for the second Zoom meeting. We're going to go over the summary assessment. It's in the orange folder. Why don't you just open it up and take a look at it? You could always attempt it once if you want. All right? And here's today's vocabulary assignment right here, okay? It's a matching, 1-question matching. All right, that's it, y'all. Thanks a bunch.